Loud and clear. Awesome. Awesome. How is everyone doing today?
Pretty good for a Friday, I imagine.
Pretty good for a Friday. I love interaction. So even though you can't see me, I'm standing up behind a huge whiteboard, behind me here. So my name is Jimmy Oyeniyi. I'm an account executive here with Databricks. I've been with Databricks now for over 2 years and having fun. Being here, just being able to help a lot of customers do a lot with their data. Analysis or just basically being able to get turn data into insights and insights into actions leveraging our tools. So I do have a technical background, so a little bit about me. Today obviously we'll talk about Databricks, some challenges that I've seen out there that customers struggle with, introduction to Azure Lakehouse with a partnership with Microsoft, Lakehouse patterns, if we have time for it, what's new in Databricks, and also summary, and questions. So a little bit about me. I used to be a principal solutions architect for 12 years before I moved into sales. And I was also, I got the opportunity of working, with Tim. We're trying to get him on our close team then, right? Tim, where I was a data and AI, especially with Microsoft. Again, looking at how, Microsoft's data services can help customers reach their data driven goals. After that, I was at Informatica for, couple of years. And then I'm like, okay, you know what? I think there's a lot of good things happening at Databricks. Let's go see what's happening. The most critical thing there was our partnership with Microsoft just makes it a lot more easier to be able to basically architect Azure Database solution to our customers. And as a data enabler or data advisor or somebody that is really passionate about data, I decided to go for a Chief Certified Data Officer course, at George Mason University, again, whereby we're talking about how we can help customers do a lot with their data. Fun fact, love to sing, love to write, love enjoying the beach, and I love studying, love learning new things. So what is Azure Databricks? Azure Databricks, as most of you probably have known, we're the data and AI company, we're the pioneers of Data Lake House. Gartner recognized us as the leader in the data management systems and the data sciences, platform as well. We're the creator of Spark, Delta Lake, and ML Flow. So we have over 6,000 customers. We've raised over $3 billion in investments, and we have over 3,000 plus employees across the globe and still growing. So if you're looking, fun fact about Databricks, we have, customers from, Fortune 500s to, the unicorns, and you can see some of those, here, as well. But when we look at what the data maturity curve really looks like, right? A lot of companies really started from the left-hand side there. They clean the data, create a report, create an ad hoc report, and do a lot of data exploration, which is good, right? That is where the data warehouse, really comes. In those days, Netezza, Teradata, Oracle, Exadata, right? And it was good for what it was good for. And then customers starts to look into ways whereby they can then go into the right hand side, which is, what will happen, when will it happen, how should it happen, and automatically being able to make decision based on those type of activities, right? Predictive modeling, being able to find out what's going to happen, prescriptive, being able to recommend, and then automated decision making based on the data sets, right? So all these today we're actually running on another platform, right? We probably remember the days of Hadoop, right? And with all the Hadoop names, Whoosy, Yarn, and Flume, and all those complex stuff that we used to deal with. The challenge with that is you're now running on on two multiple on-premise solutions, right? On the left-hand side, you have all your data warehouses that are running on-prem, and then on the right-hand side, you have all these different, analytics tools that are also running on-premise, right? So as companies start to engage themselves in transitioning into the cloud world, it's becoming a little bit difficult, right? So when we look at what happened, that's a separate tool. When we look at what will happen, that's a separate tool. And each of those tools, they have their own, probably their own, complexities, right? You have to copy data from one end to another. Your data warehouses are very structured. Your data lake are unstructured, right? And then you have to copy data back, and forth from one system to another. And we also recognize that there is also probably an issue around disjointed and duplicative data silos as you start to copy from one system to another. Now, there is nothing wrong with those. It's just that, when you look at an Hadoop architecture whereby things are replicated 3x, you can start to figure out, 3x of data, multiplied, and then trying to do some sort of, relational mapping between the two. It becomes extremely difficult to be able to keep track. And then each of these also has its own security and governance, right? One basically focuses more on files and blob storage. The other one focuses on probably HDFS and so on. And so there is an incompatibility in terms of the governance that, within the platform, as well as security across the platform. And then when you look at the data warehouse side, right, the specialists there that are touching that data and figure out what will happen, figure out what happened, they're your business intelligence expertise and SQL analyst expertise, which is good. They know SQL, they know how to query using SQL, they write their select stars and joins, and so it's good for what it is good for. When you start doing exploration and data science and data streaming and data, in motion and all those different types of real-time architecture, it becomes a little bit difficult to be able to map those together. And each of these requires separate skill sets. So with that being said, there is an incomplete support for use cases, incomplete support for cooperation, collaboration. And so when you start to look at some of these things, you can see where complexity starts to prove itself to be kind of trailing in, right? So the system is too complex and expensive, and so it's really hard for organizations to be able to take advantage and look at what is happening. So how can we get rid of some of these issues, right? So having the right foundation is extremely critical. And this is where our partnership with Microsoft really comes in extremely handy. So when you look at all those complexities and all those things that I've talked about, with Azure Databricks and Azure Synapse, we basically, are able to address those issues. They run within the same environment. They run within the same platform. They run on top of ADLS Gen 2 and Data Lake. So there is no need for replication of data, right? So all your compute, all the work that you're doing, all your machine learning, your landing zone, all those can be in Databricks, and then you can downstream some of the reporting and analytics, data that is conformed down to Azure Synapse. There are also other tools within the Lakehouse architecture around machine learning, being able to integrate that within the system, as well as Power BI, being able to curate data and have those things in motion. Now, when you look at, the curated data, how do we curate that data? The good thing is we sit on top of ADLS Gen 2, which is amazing. So storage is one storage. We're not replicating storage. And on top of that storage, we have what is called the Delta Lake. If you look at Spark in general, Spark is good for what is good for compute, for analyzing data and being able to do distributed compute. But the challenges with Spark is Spark doesn't give you the ACID transaction, doesn't give you the versioning, the rollback, and so on. And so Delta, on top of your ADLS Gen 2, gives you the additional functionalities around data management, data governance, ACID transaction, data versioning. And when you're doing a lot of streaming type architecture, then you have structured streaming, as well. So having the right foundation is really critical. And so Databricks in partnership, with Azure, right? We look at your data sciences, your data scientists, your data engineers, your SQL analytics. Every single person can collaborate on the same platform. So when you look at Databricks and what we offer, Databricks is again provides an environment that allows you to be collaborative. It is open. in the sense that when you look at Delta and some of these assets, you're not locked into a particular vendor. So Delta out there is an open source. What you get with us is that managed Delta. So that way you're not, obviously creating the security, the governance, all these things from ground up, and you're leveraging the tool to do what is really good for us. So the architecture itself is extremely simple. It's open standard, based on open standard and open framework, and is also an extremely collaborative, environment that your data engineers, your data scientists, as well as your SQL and BI users can start to take advantage. So this is for me what a lake house looks like with the Microsoft Azure Data Services. As I mentioned earlier on, I used to work at Microsoft. I used to be a data and AI person, there, at Microsoft. So a huge passion, working with my customers and our customers to be able to come up with these type of architecture. So as you can see here, you can have all the different data sets coming in, your data sources, right? Those can come in either through batch or through landings or through real-time streaming. So if you have things that you want to do on the fly, like user-based pricing, real-time scoring, fraud detection, all those can basically come in almost as real time into your environment, and we have a streaming architecture that allows you to be able to do that. When you're looking at doing like long-term architecture, like batch processing and ETL, then there is the ability to be able to, do some sort of mapping using Azure Data Factory into your landing zone as well. So real time, we can do structured streaming and stream ingestions and analytical, or just moving data in, either from an FTP file, or you're moving data in from a database, or you're moving data in from email. Things like that are not streaming, you can also bring those type of workloads into the curated data lake. What I like about the data lake is in the data lake, you have access to a lot of data, right? And so running on top of the Microsoft Azure platform gives you that compute engine to be able to run some of these at a lower cost. What am I saying? I'm saying that when you look at compute, on Azure, when you look at development environment, for example, you can enable things like spot instances, right, to be able to save on the computer. You can run, jobs in an automated fashion, so you can save on compute. So having this platform is really, a great step to being able to look at your raw data, look at the filtered data that is probably being cleaned and augmented, and then your business aggregate, the gold data. This is where you can downstream it down into Synapse to do reporting on analytics, or you can also use a combination of both SQL Analytics and Databricks SQL as well for doing things around, again, just doing, BI type work. But the key thing here is after that data is now in the landing zone, your data engineers can start to do a lot of curation and ETL and collaborate with the data scientists to be able to do things around, using open standards out there like MLflow, using Azure Machine Learning, which is a drag and drop tool. We support Python and R with that tool. So if you're a data scientist and your Python, skills, come on over. We love it. If you want to build things in Scala, we love it. If you have an SQL background, we love it. If you have, our background, just coming in and let's all party together. So this is a proven architecture, and you want to make sure that you are using a compute multi-distributed architecture for your processing instead of using an MPP architecture for doing a compute type work. Right. So when we look at like a lake house, paradigm, set here, data can come, as I was saying earlier on, data can come from a connected device, social media, videos, data aggregators, weather, and all these things can come in. So sensors can be real time, for example, or semi-streaming. Sales policies can be, structured batch. Weather can be structured streaming, and they might even have connected devices that might actually be, real time. The goal here is to be able to land everything into the data lake house, which is again in this particular architecture on Azure is the combination of, obviously, Azure Databricks as well as Azure, Azure Synapse. and we also have the ability for you to be able to leverage what is called, SQL, Databricks as well, to be able to do some of this work, right? Depending on which environment you're in and where you are in your journey. So your data scientists can come in and do ad hoc data science work. They can, do some exploratory machine learning work. They can do business intelligence with Power BI, which I love leveraging. And then in terms of real time, we can also have real time dashboarding, but we can also have real time decision making. So your companies can start to measure, the objectives and key results. So what are the different lake house patterns that I have seen? And I think I've mentioned this, earlier on. So a simple architecture, which is open, collaborative, and obviously allows you to be able to handle a ton of data. This is a slight architecture here as well. Your raw data might come in via streaming, might come in via scheduled trigger on Azure Data Factory, and there's some open and other tools out there, right? Like Fivetran, that you can also use for doing ingestion, when Disco can be used for doing your migration from an Hadoop platform into the into the data lake, into the lake house. And you have things like stream threads that can actually allow you to bring in streaming data, and then things around Click that you can use to analyze, and then visualize the data. As part of the architecture, we have a couple of things. One is, on top of that curated data lake, you have your Delta engine, obviously, the Delta engine. And here, there are a couple of things that you can also do, right? We have the notion of auto loader. So if there are documents that needs to be loaded automatically, so you can do analysis and you don't want to use complex ETL tools, there is the ability to do that. Delta Live Tables, which is another component that I really like, it actually streamlines all the complexities that is involved in creating a pipeline, right? So here you can actually, specify and create an expectation and say, hey, you know what? These are the things that I need. These are the expectation from this pipeline. These are my data quality rules. These are things that I need to be established. And it would go and create all those different outcomes for you. It will check and make sure your data quality is up to par. It will check and make sure that you are, when you're building some of these outcomes, you're building according to standards that you've described in the expectation. And this gives you the flexibility to be able to, again, cut down on time in terms of being able to build pipelines. So when you're building pipelines, when you're building ingestion pipelines, producer or consumer pipelines, you can leverage things like Delta Live Table to be able to streamline, some of those type of work items. And the last but not the least is unified batching and streaming, right? So this platform on top of the Azure, data services gives you the flexibility to be able to unify, your workloads, right? From a machine learning standpoint, I also, again, here, this is where we start to look at things around, how can we, when you're building machine learning tools, you have to think about, okay, how do I look at, where are those models? Where are they? How can I orchestrate those models? How can I evaluate those models? And also, how can I track those models? And how can I take those models into production? So by building on top of, again, for a data sciences team who are using Azure ML or ML Ops, the tool gives you the flexibility to be able to, leverage things like, building out, a feature store on the data lake, building out things like AutoML, because some people might not be very conversant with building out ML, right? So by running an AutoML, you can actually generate some ML codes, see what it looks like, and then you can decide, if you want to add additional functionalities to that or not, right? It's really up to you what you decided to do, from there on. So this is where you start looking again around things like, how do I prepare the data for feature engineering and make sure the data is up to par? As I was mentioning earlier on, DLT, which is Data Live Tables, can also be a part of that. And you can also do things around model training, model selection, model productionization, and then obviously, model serving and inferencing, and also relational inferencing between some of your models that you probably built. So the models that you've built might be, around things like k-means clustering, might be based around things like regression analysis, might be based around things like logic, regressions, whatever it is, you can leverage some of those outcomes and outputs using, Azure Databricks as well as the Microsoft Data Services as well. So Databricks machine learning, it's simple to use, it's open standards, as I mentioned, it's very collaborative. You can start to build ML ops, footprints and just things that you want to basically have on a regular basis, on an automated basis, and capable of doing ML on any data size, any data type, because in the lake, the data is different types of data. It's structured data, it's unstructured data, it's semi-structured data, it's blob store, it's images, it's just data in your lake that you can curate. And then we also have, from an analyst experience, there's also under the hood and also built on a photon engine, which is again multi-parallel speed of light. If you're hearing photon out there, you can do some research on what it is, but it's simple and performance. So your developers who are SQL developers, again, this is not replacing a data warehouse in any way, but when you're looking at developers who just want to run like a SQL under the hood to be able to just do some, integration with, let's say, Power BI and so on, a SQL user can have the ability to be able to integrate, with tools like this. So it gives you that analyst experience, gives you that admin experience, and it also allows you to create SQL endpoints that you can share with people within the organization. They don't need to know what the SQL is. All they need is that endpoint, and they can go in and query that data. And I'll also talk a little bit about how we can leverage Delta sharing, as well, within your organization. So that Databricks SQL under the hood, it's again, ANSYS SQL make migrations easier for the future. High concurrency, finely grained security that is tied into Databricks and the Azure security as well, because it's all Azure Databricks. Everything within this platform is integrated with the Microsoft environment. So Azure Databricks Lakehouse platform, it's simple in the sense that, it's an open architecture, it's proven, and then your data sciences can all, start to collaborate and start to do things. So it's simple, it's based on open standards, and it also allows your data scientists, your data engineers to be able to collaborate and work and work together. Okay, so before we go into what's new, any questions? I know that's been a Zoom by. Uh, you know, um, Team, do people have questions? I know I'd gone over, the lake
I,
house platform, the lake house architecture. I'd love to know what other people are thinking about in their lake house journey on Azure Databricks
yeah,
or.
yeah, I see a question being formulated by George Carlisle, but he's still typing. So
Okay, cool.
kind of,
Just let me
I
know.
see the graph. Oh, here we go. I see the graph, but I would use, but why would I use Data Lake House over Data Lake, Azure Data Lake? So I see the graph, but why would I use Data Lake House over Data Lake?
So he sees the graph. Which graph?
Graph, I don't know.
Okay, so I can answer that question though. So Azure Data Lake, right, is again your. So when you look at two things, one is, on Azure itself, right? Azure's Data Lake is a combination of Azure Databricks and ADLS Gen 2. That's Azure Data Lake, right? When we're looking at the lake house, right? The lake house is where, sorry, when you look at the lake house, yeah, the lake house is when you then look at a combination of the data lake as well as the data warehouse. Now, the question there then is, if I already have a data warehouse, right, my data lake can still be on Azure and I can leverage your data warehouse as is, right, and connect with it. On Azure, on the other hand, we're all within one ecosystem. So if you have Synapse in place already, they're all within the same ecosystem. Your data lake, which is a combination of Databricks and ADLS Gen 2, can have access to your Azure Synapse. So those two make up the Lakehouse platform within the Azure ecosystem. Today, I think Azure has, like Spark pools, but we know that there are some, performance improvement, but with the partnership within Databricks, it makes sense for us to leverage Azure Databricks on top of the Azure ADLS Gen 2 as a data lake. Does that answer the question?
Yeah, I think so. I believe so.
Awesome. Thank you. Awesome.
Thank you, Jimmy.
Oh, not a problem. Not a problem. Yeah, we love Microsoft. So when you start looking at your data lake, right, or you start looking at your lake house, or you start looking at all this new terminology that is coming on board, and I was actually telling someone, that you have your data warehouse, right, and you have your data lake, right, and they basically took data out and make, okay, you know what, data lake, we're going to take the lake, and then data warehouse, we're going to take the house. So together we have data, we have what's it called, lake house, which is a very nice terminology, by the way, right? It just means that within your lake house you can do everything. You can do all the work that has to do with all the data lake type stuff, and then with the Azure Synapse you can do all the data warehouse stuff, and together we are the lake house. That's a good ringtone to it, actually. So, but the challenge here is when you're looking at the lake house, a lot can go wrong, right? So your data consistency can go wrong. Your data visibility can go wrong. People can start to use, different. For example, if I have a customer object, right, and Tim creates a customer object, and somebody else creates a customer object, right? So everybody is leveraging different attributes for customers, and there's really no governance tied into what exactly does a customer look like, right? By having governance in place, we can say, okay, you know what, if team is already built a component called customer, for example, we can go in and look at all the attributes that are tied to that customer. Who's using it, when are they using it, what's the lineage, right? So what Unity Catalog does is it gives a fine-grained governance to data and AI on the lakehouse. So you know who's accessing your data. You have the same security framework, and it's centrally managed and audited and managed all types of data. And it works in existence with your existing data storage and catalog like Azure Purview, right? So there's really no hard migration. If you also have like Calibra, for example, the Unity catalog can have access to those as well. The value that Unity Catalog brings to the table is the ability to be able to understand what is in your lake, right? Because remember, with Unity Catalog, we'll have access to your lake because the Unity Catalog is built on top of, the data lake, right? With Delta. So, here when you leverage the Unity Catalog, you can do some research on it. It's on private preview right now. You can see how you can leverage the Unity catalog. The good thing about it is it gives you a track of what is in my lake, who is using it, who's dependent on it, what would I break if I change an attribute or change a field, what is the downward effect when I change an attribute or change the definition of an object, right? So that's really, and what also is the security impact if I change, a group attribute from one group to another, right? So these are the things that that a Unity catalog would help you manage your catalog and make sure that the data in your lake doesn't turn into a data swamp, right? So that's an example of Unity Catalog. Again, it's scalable across cloud catalogs like Azure Purview, combines best of breed with data security, auditing, usability, everything, because we're centralized catalog platform, takes advantage of the Azure ecosystem as well. So it gives customer a centralized catalog to all their data in the data lake, and define once, and you can secure all the time. And last but not the least is all the data is governed and secured at the account level also across all the workspaces that you've created within Azure Databricks, right? Some of your notebooks that you probably have created, we want to make sure that the data that the notebooks are accessing is also governed by, the attributes in your Unity catalog. Okay, this one I'm particularly very interested in, right? Because again, even though as a sales rep, my role and my goal is to sell, right? But when you're when you're a techie, sometimes you still want to play around with stuff, right? Even though I'm not gonna probably stand in front of customers and start writing pipelines and codes and so on. But what I do like when I was playing around, with Delta Live Table is the ability to be able to not only build out some of these things that I'm building and manage reliable pipeline, make ETL easy, and also building that expectation and reusability of ETL pipelines. What it also enforces is the data quality and reusability, right? So there is a panel there, for the Delta Live Table. You can build out, what are the dependencies and what you expect out of that Delta Live Table. You can set up, cluster, sizes based on requested SLAs, and it will do that for you automatically. You can check data handling, process record changes, change data capture. And so all these different things you can actually build into your Delta Live table and multi-flow tables as well, right? So if you load data into the same table from multiple sources using independent pipelines, it would help you to manage that. I actually had a customer that had this same exact question, like, hey, you know what? I have all these streams that are coming in, and I want to be able to, join them together, and I want to be able to report on those multi-streams. If you build out an expectation based on those attributes, you can actually do and derive exactly, that. And the last but not the least, part of my discussion today is, Delta sharing. I'm sure a lot of people have been hearing, about Delta sharing, right? It's an open protocol, to data sharing, right? A lot of companies now allow looking at sharing data, right? And the benefit of that is when you're sharing data, it eliminates the need for you to copy that data, right? The way we've been able to share data in the past is we put the data on a disk, and then we send it out, and we pray that that disk doesn't get stolen, or on our server somewhere we create a copy of that data, and they try to figure out how to access that data. And sometimes you FTP the data is a copy, the data doesn't sync up at all. The data you get on Monday might be different from the data you get on Tuesday. So those are all the different use cases out there when it comes to data complexities. But with data sharing, it's a fully open, without any proprietary lock-in. But what it does, it allows you to create a data set, and you can share that endpoint with customers that act, or with people that actually you feel that should access that data, and they can query that data in runtime. They can connect Power BI to it at runtime and do all the analysis at runtime, so data doesn't have to move from one point to another. It's also simple to share that data with all the other organizations as well. It makes it cleaner when you're sharing data to know that people who are accessing this data are the people that you've built in your ACLs, right? In your, in your access control lists, are people that you've actually built there to be able to access the data within the organization. Again, it's easily managed, bound by security, bound by compliance, as I mentioned earlier on. And the cool thing with Delta sharing also is your Unity catalog can have a list of all the endpoints of data that you want to share with multiple people. So you give them access into your Unity catalog. They look at the list of endpoints that they have access to, and then they can start to query that data, write a report against that data, or even build some sort of AI model on top of that data. So that is, the summary of my talk today. I know it's pretty fast. It's pretty quick. I wanted to just give people an idea, on the tool, on the Lakehouse, integration, and our Lakehouse partnership with Microsoft. I would love to hear from the team what they're doing in their lakehouse journey and how they think that they can, take advantage of, a tool, like Azure Databricks. The one thing I also want to say, which is what I really love about, obviously our collaboration, is the fact that Azure Databricks is a first party service. When I say first party service, if you have an Azure account today, or you have a developer account or MSDN account today, you can go into the Azure portal and start playing around with Azure today, right? All you have to do is create your resource group, create your storage group, and once you've done that, you can start to load data, into Azure, into Azure Databricks. So if you want to play around with data engineering type of work, you can load that. You can load your data. There's actually lots of examples out there whereby you can analyze like weather data, and then you can start to do things like predictive modeling with Azure ML. Or if you really want to try to explore as well, you can leverage things like, ML Flow if you want to start building out, some of these additional attributes, and you can start leveraging things like AutoML to be able to generate, just an idea of what that machine learning, flow is going to look like. So again, the whole platform is extremely easy to use, on the Azure platform. As I mentioned earlier, I'm biased towards Azure just because, I used to be an Azure data specialist. But all this thing as well, you can also, do on other platforms, Google, Alibaba, or AWS. So, all these features and functionalities are available, across the multi-platform and multi-cloud as well. So if your organization is embarking on a journey whereby, you have a multi-cloud or hybrid cloud, strategy, then there is whatever you build in, one cloud is definitely available on the other cloud as well. And what I've seen some companies do is they use, clouds like Azure and probably use, let's say, like AWS for failover, something of that fashion. But the good thing is, it's cloud native to Azure, and then, all the data sets that you've built are readily available for developers and business users to be able to take advantage of. Over to you, Tim. I think that's all I have, for today. Any questions?
Oh, we got George typing another one, but good presentation. I like how concise you were on just describing your Databricks platform. One thing I would say when you talk about if you're using trial resources and you're loading up analytics workloads,
Yeah.
pause them as soon as you create them until you're ready to do some testing against the
Yes.
workload,
Woo!
because it will gobble up what you got in
Yeah.
terms of your trial resources. So once you get your Databricks footprint, or
Mhm.
Azure Synapse SQL pool, just
Mhm.
pause it until you're ready to run a workload against it.
I love that. I really do actually. That's such a great way to look at it. So you can, when you dump all your data in the lake house, right? Before you start doing all the analytics work and downstreaming, to, Azure, Synapse, and doing all those stuff, you exactly want to do that. You want, there are a couple of things that you have to do first, and I love
Right.
George's question. The first thing you want to do is make sure that when you're selecting your compute engine, you want to make sure you don't overshoot yourself in terms of, because I've seen, some customers who basically say, hey, you know what, I want my job to run faster, so I'm going to pick the biggest box, which is okay for me as a salesperson. But what I typically would recommend is take a small set of that job, do a small analysis on that, get a demand plan together. Once you have that in place, that would give you an idea of what your demand is going to look like. And then you can start to provision some of these environments based on that. So we have the notion of what is called a t-shirt sizing, and then you can start to build out some of those based on your on your demand plan. Now, the one that might be a little bit difficult is streaming use cases, because streaming is almost real time, unless you're doing streaming in a sandbox, right? But again, those type of things, I really do agree that You have to do some sort of analysis before you switch the box on. And also with Databricks, you have, all-purpose jobs, which basically are jobs that are just running, right? They continue to run. You can do your exploratory work on them. You can do your analytics at runtime and so on. But there are also some jobs that are just automated, right? You just want them to run. It might be a cron job, for example, right? And so the interactive clusters are a little bit, expensive, right, to run compared to jobs that are just running. So you don't want to run a job or cron job on a what's it called, all-purpose cluster. So my thing is, when you finish doing all the work and you want to put some of those workloads in production, I recommend switching from your all-purpose compute into the job clusters. I know it's a lot of good things, but George just gave me a lot in there that got me excited. Sorry. Did I lose everybody? Hello? Everybody still there? Can you hear me?
Still here.
Yep, we can.
We're still here. We
Okay.
can hear you.
Still hear you.
Okay, good. You guys are quiet on me.
No, Teams died on me temporarily because I put my stupid laptop on the docking station and all of a sudden it burped. So you were it sounded like I was had left the meeting, but I'm sorry.
No, no worries, no worries. I said George's question got me excited, so we keep it coming. Any and anything else there that I can answer?
How about it, guys? I think we might be good. I think our brains are full for a Friday afternoon. You know how that goes.
Yeah, I try to make sure that I cover it in the concise amount of time. So if you have any questions, Tim can send you, my email. I love, Tim knows me, I'm a fanatic for, just learning more, right? How to be data driven within organizations, right? How to understand multiple use cases, right? Even though I'm currently in the financial services here at Databricks, I had the pleasure of working in retail as well. I've seen a lot of use cases around supply chain optimization. I've seen a lot of use cases around hyper personalization. I've seen a lot of use cases on customer churn, customer lifetime value, customer retention. And I've also seen a lot in the industry around, again, pricing, actually user-based pricing, leveraging things around telematics and so on. So if you need anything, I can take my sales hat off and, just spend some time with you if you need me to. But thank you so much for the opportunity, team. I wish I was able to show my handsome face, but, we'll do that for next time.
Well, they'll just be stuck with my handsome face. But thank you very much for your time, Jimmy.
Yes.
Thank you all that tuned in. And we'll have this posted up on our YouTube channel here within the next 3 or 4 hours.
Awesome. Have a good one.
Thanks, everybody. We've got some thank yous
Bye.
coming in. Thank you, everybody.
Bye.
Thanks, Michelle.
Bye.
Thanks, George. Bye-bye, guys. I'll stop recording.